Okay, so what I'm going to do here is do a Google search for desmos. Press enter. DESMOS. This is being used more and more in schools across the country. It's free, which is nice. It's also got lots of teacher desmos here. You can integrate geometry, statistics, algebra. So it's a good all-in-one package. It's even got specific classroom activities, and you can even build your own in there. So I'm going to go start graphing. And it's also pretty simple to learn. It's not one of these packages that takes a lot of time to really get into. So I want to graph this function right here. So I'm just going to start typing it in. D of t equals. And I'm not quite sure if that is going to work or if I'm going to need to change that to a y and then later to an x, but we'll see. Then we have 21,500. I'm not sure if a comma will hurt me here. It might think that I'm doing two separate points, so I'm not going to put it in. It's certainly not going to hurt me to leave it out. And then we have cosine of 2 pi over 27.3. I'm going to type that in, cosine of 2, and I'm just typing the word pi and then a division sign. And then it was 27.3, and then I'm going to hit the right parentheses. Whoops. I'm going to hit the right arrow, then the right parentheses. That'll close my parentheses out. And then we have the t minus 2 there. T minus 2. And we have plus 384,500. And again, I'm not going to put that comma in. Okay, so it's not giving me an error. Here there would be like an exclamation point or a warning sign if there was an error. So I think it's graphing it so far. So one thing I noticed is I have this plus 384,500. So whatever value I'm going to get here, I'm going to add 384,000 to get the y-axis. In other words, I know I'm really far away from this x-axis here. So what I'm going to do is I'm going to hold down the control key and scroll down. This may be slightly different if you're on a Mac. I do see a line there. It's a good sign, I think. I'm going to keep scrolling down. Something's starting to look suspicious because I'm seeing that line, but I'm not seeing any pattern beyond that. So for some reason, it's not really running the cosine cycle, but I'm going to go ahead out until 384,000 just to see. Okay. So now I'm at 500,000 and I'm not seeing anything to the left and right. So it looks like whatever curve I'm graphing is just hitting this. And if I look at this closely, I think I know why it is. This would happen in a situation where we didn't really make use of the cosine function. In other words, the cosine function is not including the variable. So if I look at that closely, I notice that this part, the cosine, does not include the part that's t. If it does include the part that's t, it should have some kind of repeating pattern. So somehow I need to get that inside the thing. So maybe it should be cosine of this entire thing right here. That would at least give me a t inside there. I'm not seeing any. Oh, I'm seeing a warning. The way the equal sign is used here. Okay. Yeah, somehow it's not. Maybe I didn't put that. Do I need another? Feels like I'm doing too many. Okay, well, somehow I don't think I needed that many here. I'm going to take out that parentheses. Okay. Yeah, that looks a little cleaner. Still, I think there's still too many parentheses there. But it's not going to hurt us. It just looks weird. Okay, so I'm seeing some kind of repeating pattern there. So I'm going to zoom in on that. That's got promise. Okay, and it's too packed together now. I need to bring that scale out. So I'm gonna, let's see. I'm not really sure to do this. So I'm going to Google how to change x-axis scale in Desmos. Okay, there we go. So basically it looks like I go to settings, this little wrench, and that x-axis right now is between these really huge numbers. Maybe I just want it between, I don't know, negative, well, let's just even do 0, 0, and 10,000. Okay, that's too much. 1,000. Okay, 100. This lets me see much better what's going on. I'm going to close that. Okay, and then I can see these labels in there. So now it's about time to take a peek at what the original problem said. So it should go between 363,000 and 406,000. And if I click in, I can see that I just left clicked on the graph itself. It looks like 363,000 is the low point. 406,000 is a high point, so that's good. When it's at apogee, it's about 406. Moon will reach its apogee on t days after. So the moon will reach its apogee when t equals 1, because that would be, t is the number of days after January 1st. So January 2nd would be 1 day afterwards. So when t equals 1, it should be 406,000. So let me take a look at that. When t equals 1, and what I'm going to do, I'm going to put a line in t equals 1 and just press enter. Okay, let me just do x equals 1, and that'll let me see where these two intersect. So noticing there when x equals 1, or when t equals 1, the function is 405,000. So that's not quite right. So something here is shifting off. What if I do t minus 1 here? Now it's 406,000. And I just kind of wondered about that because we're 1 day off of the apogee when we start. So instead of putting a 2 for 2 days off, I wondered if it'd be 1. And my guess is now we're going to hit everything else out. The apogees occur 27.3 days apart. So I think another thing we could do is put an x at 28.3 and see if that's another apogee. Yep, 28.3 and 1. So those high points are now 27.3 apart. And looks like that's all the criteria they give us. So this must be, it's meeting everything they ask for. Not that one, sorry. This looks like, if I stretch it out here, the correct function that we found. And one other thing, when you see these are called sliders, and they allow you to play around. So if I wanted to see, like, on day January 6th or something, I could put this at 6, and then I could just click here and find out that, okay, it's 393,267 feet there. I could do a similar thing if I had the apogee of a different length or something, or whatever the case. You can put these sliders in and just see how it impacts stuff. I could have made this a slider, and then I could have changed the value of the function also, but that's not really applying to this particular question.